Okay. Nani dah datang. Sekejap, Nani dah record tak? Okay, dah record dah. Okay. So, today will be covered on the electromechanical system. Okay, how to define the transfer function from the electromechanical system. Okay, meaning it's a combination of electrical and mechanical system, which is from this topic. I will be introduce DC motor, okay, and DC generator. How we want to control the DC motor, DC and DC generator by the armature circuit and field circuit. Okay, we have electrical circuit. It's one subsystem. Okay, let's say we have. Hopefully everybody still remember the block diagram. Okay. The closed loop block diagram. Okay. From here, meaning this is the output. Okay. This is your input. And this is normally is the controller. Okay. The controller and this is the actuator, right? Actuator and the last subsystem is a plant or system, and then this is the measurement element. Okay. So from here, I want to control the DC motor, meaning DC motor is your actuator. There will be receive the current from the controller. So this is your armature circuit or your field circuit here. Okay, and the actuator or the final control element is going to be is your DC motor. Okay, and the plant will be defined. What is a plant for this electromechanical system? And then from the plant, you can see the output, and then we will measure the output using using this mechanism or this subsystem. We measure the output. Okay, we measure the output using measurement element. Okay, we will define what type of measurement element we will be going to use. Okay, let's say from this example, we have two type of the measurement element or transducer. One is a potentiometer, another one is a tachometer. First, remember, we use the tachometer to measure what physical output.
Speed.
Yes, good. We measure speed. We convert speed into voltage. Okay, meaning the input is a speed and the output is a voltage. Okay, that's from the block diagram. Okay, so from the block diagram, this example, we have four subsystem. Okay, you have to define the transfer function. Okay, for today, I'm give the electromechanical system. The first one will be covered on the armature control DC motor. So, and what is a load and what is a plant? Well, I will be given in this example. So, uh, we go through the first study, armature control DC motor. Okay, before that, is it everybody go through this circuit before you join our class? Baca tak? Madam dah sediakan kat sini sebab nanti, sebab dia is uh, banyak pada mechanical tau, more on mechanical. At least you tahu what's going on when the motor is rotate in etc. Okay, so just through scan. What is a motor actually? Okay, a motor is an electromechanical component that yield a displacement output, meaning output from the motor is displacement, meaning displacement is an angle, okay, or x, depends. If a rotate, is a theta, right? displacement, whether X or whether angular or X. Okay, this is the output. Okay, from a motor is an electromechanical component that yield a displacement output for a voltage input. Okay, so meaning motor is C motor, input is a voltage and the output with the get this one where the displacement. Okay, the displacement is the output. That is a mechanical output generated by an electrical input. Okay, we will derive the down function for one particular kind of electromechanical system. The armature control DC motor. Okay, so meaning we will derive the down function of electromechanical system such as armature control DC motor. Okay, the motor schematic is shown. Okay, motor is based on apa yang saya share dekat sini lah. This is our motor. Okay. Okay, this is our okay. So you can see from the figure. Okay. Actually we have I already shared one video, okay, but you have to Google this link, DC motor, how it's work, okay? After this class, I want you all get this link, DC motor, how it works. So I nak you all, I want everybody Google how the DC motor works, okay? So meaning from there we will get more information, right? Okay. So how what the working principle for the motor? Okay. So from this figure, when here, okay, this one. When electrical current pass through a coil in a magnetic field, the magnetic force produce a torque which turn the DC motor. Okay, from here we will get one information. Okay, we have torque, meaning torque we label with T. Okay, and then magnetic force F equal to this one. Okay, magnetic force F equal to ILB, act perpendicular to both wire and magnetic field. Okay, and how about here? Electric current supply internally through a commutator. Okay, from DC motor, we will get equation or we can derive from the motor. Okay, motor is a one system. Okay, what equation you can derive when the motor is what type of transfer function you can derive from DC motor? The first one, you can derive torque. Okay. Okay, this is also the explanation. Okay, DC motor. Okay, from this circuit, figure A, a magnetic field is developed by permanent magnet or electromagnet called a fixed field. A rotating circuit called the armature through which current IA. Okay, so meaning IA will be what? Through which current? IA flow. So meaning a rotating circuit called the armature will be what? They have a current flow the armature circuit, okay, pass through this magnetic field at the right angle. Okay, so meaning F force equal to B L. What's a B? B is a magnetic field. L is a length, okay, of the conductor. And then IA is a current from the armature circuit. IA, A is for armature, okay. the resulting torque turn the rotor, okay, turn the rotor, the rotating member of the motor. So meaning torque will be, so from here, what equation supposedly we can get? Torque proportional with the current, okay. Torque, the resulting torque, okay. Torque turn the rotor, okay. Because where we get torque, current flow through the magnetic field, okay. And apa? So resulting dia is a torque. So meaning torque proportional with the current. Okay, that's one equation you can derive from the motor. Okay, the second one. There is another phenomena that occur in a motor. A conductor moving a right angle to a magnetic field generate a voltage. So that's another one. They generate voltage. Okay, at the terminal of the conductor equal to, this is the question. Okay, where E is the voltage and V is the velocity of the conductor. Okay, normal in the magnetic field. Since the current carrying a armature is rotating in a magnetic field, its voltage is proportional to the speed. So meaning, this is the second equation we can derive from the DC motor. This is a fixed, right? This is a fixed equation. From the DC motor, when a armature control DC motor, this is the transfer function you can derive from the DC motor. One is a torque proportional with the IA. Another one is a VB. Okay, VB is proportional with the d theta over dt. Okay, just now. Okay, that's a voltage that proportional to the speed. Okay, we call VB. Okay, VB is a back electromagnetic force or back EMF. KB is a constant, meaning from here, we rearrange the equations. So we replace with the constant, and this is, you can get d theta over dt Laplace, you can get theta m, right? We're taking Laplace transform d theta over dt, you can get as theta s. Okay, so we can get this equation. Okay, now the relationship between the armature current IA, the applied armature voltage and the back EMF. So apa equation yang you boleh write? What equation you can write in loop, in the loop circuit around the Laplace transform armature circuit? So meaning, so what we can derive from this circuit? Okay, so meaning like this is for one loop RLC circuit. Okay, so we can derive this one from the armature circuit. Okay, and this is just now we're talking about the torque, and the torque developed by the motor is proportional to the current, to the armature current. So we can derive this equation. Okay, let's say this is also the current, and then this is substitute. Okay, let's say we directly go to our first DC motor. This one, this figure. Okay, armature control DC motor. Okay, this is armature. We have a one loop lah. Armature control DC motor, and we have a rotational mechanical system at the back. Okay, we have one system here, armature control. This is the armature, one system, and this is our DC motor, one subsystem, and then we have, what's this? This is a rotational mechanical system. Okay, this is another one subsystem. Okay, from here you have to derive the transfer function, okay, or you have to derive the equation for each subsystem. Okay, so you have to derive the equation for each subsystem. Okay, let's say we're going through our first case study. Macam control motor. Okay, first, let's say um, you have to define the transfer function. Let's say I give you what type of transfer function we have to define is we have to define angular displacement. Okay, this is our output and our input is EA. So we want to define, this is the overall transfer function, meaning overall is a complete transfer function, okay? So step one, what is our input actually? EA. EA is our input. So you start derive the equation from EA. Okay, so the first subsystem, what is the first subsystem? The first subsystem is a armature. From, I already list for you, okay, equation number one. I already put equation number one here. Okay, let's say we derive the equation from the armature circuit. So meaning, from the armature circuit, we use Kirchhoff law, okay. Supply voltage equal to, what is the supply voltage? Our supply voltage, EA, we write the component based on impedance, okay? We macam mana nak cakap? We derive the equation based on the impedance, okay? So meaning RA. So from here actually the total of applied input equal to plus VLA and then plus VB. Is it correct, guys? Total of voltage around this armature circuit. Is it correct? Everybody with me? Cuma ada dengan medium ke?
Yes.
Okay. Okay. So meaning our apply input equal to voltage through the inductor plus voltage through the resistor and plus the VB, the previous just now I'm already talking what is a VB, right? VB is our back EMF is generate from the rotor, right? So from here we rearrange this one, we can get this one. Okay? So this is VRA. So meaning here equal to, oh sorry, the impedance. Okay, what is the impedance for resistor? R multiplied with the current. Okay, plus impedance for inductor is LS. Multiply with the current armature and plus with the VBS. Okay. Okay, from here, we derive or we find the transfer function from what? From a armature circuit. Okay, let's say medium label number one here. Okay, how to derive the transfer function? So meaning you have to what? Still remember output, the statement output equal to what? Output equal to gain. Yes,
Gain times input. Gain times input.
input. Okay, very good. Okay, this is you have to rearrange the equation until you meet this keyword. Output equal to gain times input. So you have to rearrange the equation. Okay, so meaning this is voltage. This is also voltage. So you have to rearrange back. So EA minus VBS equal to R plus LAS, this is also A, right? And over A. Is it correct like this? So meaning, what is your output? What is the time function? Time function output over input, right? So output over input equal to gain or equal to the
resistance.
the resistant and plus the inductor. Okay, so meaning output is a IA. Okay, this is madam dah labelkan dekat sini. Okay, this is the equation. Okay, so what is our output? Output is our armature current over input. What is input? Input is a combination or sorry, not combination. It's the difference between apply voltage and back EMF voltage. Okay, and then equal to 1 over the total of the impedance. Okay, right. Guys, you can follow me for the first subsystem. Is it okay?
Yes.
Okay, very good. Okay, this is the way how to derive the first subsystem, meaning our first subsystem is a mature circuit. Okay, next. Next. Is this your next? This is the next circuit. Sorry, the next equation. Okay, we finish derive our armature circuit. Okay, the second you have to find out our second subsystem. What's that? Our second subsystem is a motor. Okay, from the motor we can derive two equation. Okay, apa dia tadi? Siapa remember? Back EMF dengan torque. Okay, we can derive two equation from the DC motor. Okay, the first one is a back EMF. Where is our back EMF? Back EMF. This one. This is our back EMF. Okay. One equation. Okay, what is a back EMF? So meaning our equation is actually from here. VB proportional with the d theta over dt. Okay, the previous slide, madam already discussed, right? D theta over dt. Okay, meaning from here, VB equal so meaning we define or we replace with the one constant gain. Okay, KB. KB is a constant gain for back EMF, and then d theta over dt we can get as theta S. Or simplify, you can get this one. Okay, this is the equation number 1 for DC motor. Okay, and then from there we rearrange the equation so you can get equation number 2. Okay, VB is your output. Okay, meaning just now is from here. Remember what's this? VB from this equation. VB is the output from the rotor. So of course we write VB proportional with d theta over dt. So meaning VB is our output. Okay, and then the input is the speed, right? This is your speed. Okay, and this is the gain constant for DC motor. Okay. Okay, and then the second part is you have to find out torque. Okay, torque is generate. This one, torque by DC motor. Okay, torque is generate from the DC motor. So meanings, torque proportional with the armature current. Okay, so meaning from here we simplify, you can get this one. Okay, Km consider is gain for motor torque. Okay, just now is a KB. KB is a gain constant for back EMF. Okay, so we rearrange this equation so we can get equation number 3, the time function. So meaning torque is the output. Okay, meaning just now torque proportional with IA. So meaning torque is our output and this is our input. Okay, so we can get this one. Output over input equal to gain constant for DC motor. Okay guys, we have a 3 equation. Okay, we have 3 equation. Okay, the next one. Our motor, rotor. Where is our just now? Okay, this one. Our rotational mechanical system. How to derive the rotational mechanical system. How to derive the rotational mechanical system? How to derive? Siapa ingat lagi kita dah cover dah? Macam mana? How to derive our rotational mechanical system? So meaning let's say from here, torque. We start with the torque. Torque equal to apa? The angular ni kita boleh assume as the displacement. Okay, so meaning J. Apa impedance for J? Tapi ingat, JS square kan? N plus apa? Ni apa ni? This is a damper. Damper or viscous damper, this DS. And there, apa? There inertia and damper related to motion. This one, this is our motion or our displacement. Okay, so this is the equation you can derive from the rotational mechanical system. Okay, so come back here. Okay, mana ada spring kat sini? Tipu ni. Okay, so equation ni is wrong. Is it they have a spring here? Tak ada spring kan dekat sini. There's no spring. So meaning ni tak ada. Okay. This also don't have. Okay. So we can derive the equation for rotational mechanical system is like this. Total into, we write the equation based on impedance, right? Meaning this one is the initial plus they give the previous slide. Okay, they give initial and damping ratio. Okay, and multiply with the, just now they give theta m. Okay, we put theta m here. Okay, right. So from load, this is consider our load or our plant. Okay, DC motor we rotate our what? DC motor we will rotate our rotational mechanical system, meaning from the whole system, our rotational mechanical system is our process or our plant. Okay, so from this equation we rearrange, we can get equation number 4. Okay, so meaning torque is input to rotational mechanical system and theta or displacement is our what? Our output. Okay, torque is our input, displacement is our, this is the displacement. Displacement is our output. So meaning from this equation, we rearrange or we write into the term function. Okay, we write the term function of rotational system so we can get theta or displacement over torque equal to 1 1 plus s square j, or so you can write like this, j s squared plus ds. Okay, this is the equation number 4. Okay, so now we have what? We have 4 equation. Okay, we have 4 equation. Okay, from the 4 equation, let's say from equation number 1, okay, let's say madam write this is number 1. Which one number 2 just now? This is number 2. And this question number 3. And this is question number 4. Okay, from equation number 1, let's say the question asks you draw the individual subsystem or draw the individual block diagram for the system. So meaning for system 1, so you have to draw the individual block diagram. This one is a complete block diagram. Okay, but what is the individual? Individual is from equation 1. How you want to draw the block diagram? EA, because this is, they have a difference, so we come up with the summing. Okay, this is the individual block diagram. Okay, this is your EA minus, this is your VB, and this is your impedance R plus LAS, and the output is the current. Okay, the output is the current. Okay, this is the current. Okay, that's the block diagram belong to equation number 1. Okay, equation number 2, from equation number 2, so we have KBS, and then what's the output? Output is a theta, and the input is a VB. Okay, that's question number 2. How the block diagram for equation number 3? Equation number 3, this is the Km and current here. Okay, and the output is a torque. Okay, and then how about equation number 4? Equation number 4, the output is a theta. The S, and then the input is a torque. Okay, and then this is the Js square plus ds. Okay, this is the individual block diagram represent for each subsystem. Okay, guys, you can follow. Are you with me?
Yeah.
Madam.
Okay, okay, very good. Okay, now
Yes.
we have 4. We have 4 individual subsystem or individual block diagram represent for subsystem. Okay, and then from 4 individual, you have to draw the complete block diagram. Okay, this is our complete block diagram. Okay, this one. Okay, this is the complete block diagram. Okay, the first subsystem IA, I armature is your what? Output. Okay, so supposedly they come here, right? This one. They come to KM. Okay, the KM is the output, is a torque. And torque supposedly they come here, right? And get this. Okay. Theta. Theta is our output. So meaning, we want to define the term function what? Just now. Apa madam suruh cari? Theta over EA, right? This is the term function we want to define. Okay. So, from the data, okay, we have this and this. Okay, from the data, this is our output. Okay, this is our output, and then this is also our output. So meaning, so from the output, we measure the displacement. Okay, we measure the displacement. Okay, and then we convert the displacement into what? Into voltage. Okay. So what type transducer we can use here to measure theta angular into voltage or something like that lah. Okay. So now this is our overall block diagram. Okay, this is our overall or complete block diagram. Okay, this is our completed block diagram. Okay. Okay, so once you define the completed block diagram, so you can solve using using block diagram reduction technique to what? To define the transfer function. Still remember how to define the transfer function using reduction technique? Boleh ke? How to define the transfer function? How to define the transfer function from the completed block diagram? Guys, how to define the transfer function?
Simplify dulu.
So meanings you have to
Cascade lepas tu feedback.
yes.
Lepas tu dapat lah.
Okay, good. So this is a connection, 3 type of connection. Okay, 3 type of form. Meaning the first one we have a 3 block. We can cascade that block, right? So meaning I have to label A, B, C. And then this is, let's say I put D. Okay. So A, B, and C we can cascade, right? Okay. So meaning from that complete block diagram, we have to simplify to define the transfer function. So meaning from here, we redraw back. So you can get A multiplied with the B multiplied with the C, right? So this is still our displacement. And then this is our D. Okay. And then this is our EA and this is our VB minus. Okay, we simplified. We done simplify our cascade connection. You multiply A with B and with C. And then from there, we apply what? We apply feedback. Okay, how to simplify using the feedback rules. So, theta over VA equal to A, B, C, 1, because that's minus, we make it plus, A multiply with B, C, and multiply with D. Okay, this is the transfer function. Okay, so class you have to define what is the transfer function based on the parameter given. Okay, boleh? Boleh tak?
Boleh.
Okay, okay. Madam nak you all solve So this K ni tak ada This one tak ada. Okay, tak ada spring pun kan dekat kita punya rotational tu. Tak ada spring element, okay? Okay, that's our first system or our first case study. A mature control DC motor. Okay, the second one, field control DC motor. This is the field circuit looks like. Okay, we have a field circuit control DC motor and the load or the plant is a rotational mechanical system. Okay, this is the damper. Okay, similar with the first case study, we have to derive subsystem by subsystem. Okay, meaning the first one is a armature. Okay, we have armature circuit here. So this is your subsystem one. Okay, subsystem one is a field circuit. Okay, number two is a motor. Number three is a rotational mechanical system. Okay, so let's say subsystem number one is a field circuit. Okay, so field circuit, so you have to derive this one. So you have to derive this one using Kirchhoff law. So meaning we can get this equation, right? Vf meaning is a field voltage equal to, supposedly we want to define what? We want to define voltage through this one and voltage through the LF. Okay, so we can get this equation, right? Okay, from here, so you have to rearrange to get the transfer function. Okay, meaning V is our input here. Okay, so meaning IF is your output. And then the impedance or the total impedance is your gain. Okay, so meaning hopefully you remember voltage or current can be your input or output. Okay, your component RLC is your gain. Okay, could be your gain. Okay, so you rearrange the field circuit so you can get equation number one. Okay, output over input equal to 1 over R plus LS. Okay, this is your equation number one. Okay, so how about the current? The next one. Okay, torque by DC motor. Okay, torque will be produced by DC motor. So same with the armature, but for this one is a torque proportional with IF because this is armature, right? And sorry, this is a field circuit. So torque proportional with the IF. So we simplify, you can get this one. Torque Km is a constant coefficient for motor. Okay, and IF is a field circuit. Okay, so you rearrange, you can get this one. Torque is because torque proportional with IF, this one. Torque means output. Okay, torque is output. They're proportional to the current. So from this equation, we know torque is output and IF is your input. Okay, so we can derive the transfer function is similar like this. Okay, torque equal to, or from here you can put like this, output equal to gain time input. Okay, so meaning output, what's the output? Output is the IF equal to sorry. Salah. Output is a torque. Okay. So from this equation, you compare with the equation you derive already. Torque is the output, gain is this one, and I is the input. So from here you rearrange so you can get the transfer function. Output equal to input, output over input equal to Km. K is a constant coefficient for motor. Okay, the next one. Rotational mechanical system. Okay, rotational mechanical system. Ada. And also don't have. Okay, so you can derive from the rotational mechanical system total of torque in terms of S domain. They have inertia and they have a damper. So meaning inertia is the impedance for inertia is a J squared plus the impedance for damper is a ds, and what's they're related to the angular M. Okay, so what is our output? This is our output and this is our input. So you have to rearrange our equation to get this one 1 over J square plus ds multiply with our torque. Okay, so from here we write the term function. Theta output over Tm input equal 1 over Js squared plus ds. Okay, 1 over Js squared plus ds. Okay, that's our rotational mechanical system transfer function. Okay, we have a 3 equation. Okay, and we have 3 individual block diagram supposedly. Okay, so this is our equation 1 from subsystem 1 ni from our subsystem number 2 from the motor, and this is from our rotational mechanical system. Okay, so consider this is I give you the complete the complete block diagram. Okay, from our first case study, the system is a closed loop, right? Because they have a feedback. For this second, for field control DC motor, this is an open loop. Is it? This is an open loop system because they don't have a feedback element here, right? Okay. Yeah, they don't have feedback element. Okay. So meaning this is an open loop control system. Okay. So what's the individual block diagram for equation number 1? So meaning let's say you sketch equation number 1. So meaning you can get the output is I field, and then this is your input and this is your gain L F. Okay. The second one, what is the second one? This is a KM and TM is the output. I'm sorry. Okay. TM your output and then the IF here. Okay, this is your current. This is your IF. Okay. And then from equation number 3, equation number 3, one over Js squared plus ds, and the output is a theta or angular displacement, and then here is your torque. Okay, total of torque here. Okay, so from 3 subsystem you combine. Okay, you combine. Oh my god. Okay, you combine so you can get this overall. Okay, this is the overall block diagram for that field control DC motor. Okay, so this is the overall or completed block diagram. Completed block diagram. Okay. Okay, from the completed block diagram, so you have to define the transfer function. So what is the transfer function? Apa transfer function dia? Data or angular displacement over first the input if equal to, let's say this is A, this is B, this is C. So meaning cascade. A multiply with B multiply with C. Okay, this is the transfer function. Okay ke?
Okay.
So far so good?
Good.
Good.
Okay, very good. Okay, right. Okay, this one. Apa ni? What is our next system? Field control DC generator. Just now field control DC motor. This is field control DC generator. Field control DC generator. Okay guys, can you derive the equation for this system? Okay, try. Apa subsystem dia? What subsystem you can observe from field control DC motor? First subsystem. What is our first subsystem? Huh? Field circuit. Is it? This is our field circuit.
Yeah.
Okay, number two. DC generator kan? Okay, number two, DC generator. DC generator. Okay? Cubalah derive. Try derive. Apa you can get equation from there? Siapa boleh derive? Siapa boleh cuba? How many subsystem we have? Field circuit, DC generator. Ada lagi tak?
Tak ada dah.
Okay, dua saja subsystem kan? Okay, the first one, you have to derive lah. So, how to derive? VI is our input.
BIS equal to
Okay.
IF.
Okay, so meaning kita buat impedance terus Plus
Yes.
LFS
Plus
multiply
LSS.
with the IF.
IFS. Yes.
Okay, so okay, from here,
Output and input gain.
okay, so meaning output is IFS
IFS over
equal,
BIS.
okay, ni R
F plus LFS
plus
LFS
LFS multiply dengan,
BIS.
okay, from here you directly put your sketch your block diagram. Okay, meaning what is your input? Is the
BIS
1
in the
over
box 1
RF.
over
Okay.
RF plus
Output
LFS
dia adalah current.
IFS.
Betul tak?
Yes.
Ini S. Okay, this is our subsystem number 1. Okay, number 2, DC generator.
DC
Okay.
generator.
So, apa equation yang you can derive? What equation you can derive from the DC generator? You see there, V0. V0 is a output or generator voltage or voltage generator. So, apa equation you can derive from there? From the V0. What equation you can derive from the V0? V0 is our voltage generator. Okay. So, voltage generator proportional to what? Okay, V0 ni is output. Okay, so output proportional dengan apa?
Generator.
DC motor.
Output maksudnya our DC generator will be operate from the which current? From which current? V naught sama dengan V generator. Okay. So let's say lah we put V generator. Proportional with apa? Proportional with what? What V is our output. Okay, our output is reflect to what? Reflect kepada apa? Water generator.
Inductor.
Water generator kita is based on apa? Water generator kita dia receive apa from sistem sebelum tu untuk dia operate. Remember tak tadi kita buat dekat sini motor? Motor? Mana? Ni. Our motor will receive what? Untuk operate. Motor kita receive current kan?
Yes,
Motor kita
current.
receive current. Okay. So, dekat sini, kalau yang tadi tu, dia ada torque. Torque proportional dengan IF. So, untuk generator, untuk DC generator, dia akan ada V0 ataupun water generator. So, water generator dia proportional dengan kita punya current IF. Okay. So, VG proportional dengan I feel. Maksudnya current is bahagian sini adalah kita punya controller. Okay, bahagian sini adalah controller. So, current yang akan lalu ni dia akan operatekan kita punya generator. So, of course, output yang terhasil VG adalah output generator. Ni adalah output generator. So, output generator ataupun potential of generator. Dia panggil VG lah. Macam tu kalau refer pada note saya tu. So, output generator is a proportional pada current. Maksudnya, your VG, your output generator is based on current. Okay, so we can derive the equation. VG proportional by F. So, we simplify this one equal to, we give one constant speed. Let's say I give you kg. Okay, we can get this one. Okay, IS in term of IS domain. Okay, so VG is our output equal to gain and this is our input. So meaning you no need to simplify this equation. So if you sketch a block, you can get what this is here? Current. Okay, and then what's here? What's the gain is a kg. And what's the output? Output is a VG. Okay, this is your output. Okay, so we have two blocks represent what? Represent field control DC generator. Okay, so this one and then so let's say we combine two block. So apa you akan dapat? We combine this block and this block. So we can get open loop or closed loop? Guys, we can get
Open.
open kan? Okay.
Open.
This one R plus LFS. Output dia adalah, sini adalah current in term of S. Dan ini adalah kg. Okay, this is kg. Dan output dia adalah VGS. Okay, so from here, you have to define the transfer function. What is the transfer function? Transfer function is a VGS over applied voltage equal to, you cascade this one. So you can get kg over RF plus LFS. Okay, this is the transfer function from the amateur control DC generator. Okay, Ada soalan? Any question?
No.
Okay. So far so good?
Yes.
Senang.
Yes, madam.
Senang aja kan? Okay, quite simple, right? Okay, quite simple. Okay. So let's say, alah, I dah tulis dah nama. Okay, this is a symbol for potentiometer. Okay, this is a symbol for potentiometer. What's the output from this potentiometer? What's the output? Guys, what's the output from?
VO.
Okay,
VO.
okay, good. So VO is our output from the potentiometer. Okay, so meaning VO. And this is theta. This is a linear potentiometer or rotary potentiometer. This is a linear potentiometer or rotary potentiometer. I give you angle.
Rotary.
Okay, rotary because this is a label with the angle, right? Theta. Theta normally is
Yeah.
something. Theta, this one, this symbol is a something to rotate. Okay, this one, angle. Okay, this is a something to rotate. This is a rotational mechanical system. Okay, based on rotational. Okay, so meaning we not proportional with what? Proportional with this one. Okay, we not output from the potentiometer is reflect to what angle you adjust, right? Okay, of course, this is the output based on or proportional on input. Input is the angle. Okay, this is a potentiometer. How we want to write equation for potentiometer. Okay, next one. Okay, similar like this. Okay, the time function relationship is between output voltage and input angular displacement. If the center location, okay, we know is 0 lah, okay, right? 5 turn towards either the plus 10 or minus 10. Okay, so you can get like this. Okay, Vi over Vi equal to this one, can get this. Alamak, sekejap apa tadi? Where we are? Okay. From here actually we can derive the time function. Time function equal to potential time function of potentiometer Vi input over output equal to this one. Okay, actually from the time function we can derive what? Vi. So let's say we not proportional with the angular. So meaning we not equal to let's say I give the constant coefficient for potentiometer and uh, theta. Okay, so meaning let's say from here, uh, what's the input? Yeah. Sekejap. Betul ke tak equation dia ni? Mana mouse? Sekejap. Hold on. Okay. Potentiometer. Okay. Oops. Potentiometer. Potentiometer. VI is our input. Salah je ni. Sini kita nak define V naught dah V naught equal to the potentiometer. Let's say voltage divider. Voltage divider meaning let's say this is R1, this is R2. So let's say we want to find out V out is here. V naught equal to R2, R3 and then multiply with the VI. Is it like this? Betul tak?
Yes.
Okay, so from this example, VI is our. Supposedly this is not VI. Oh, okay. This is a VI output. Let me check this question. I think something wrong with this question. Supposedly the output is a V naught. Okay. VI input and the resistance is a gain. Okay, let me check this one. So I put KIV. Okay, I put KIV for this potentiometer symbol. Okay. After this, I come back. Okay, now we go to the tachometer first. Tachometer or DC generator. This is tachometer. The previous one, I give you what? I give you apa? DC generator. Okay, similar also with this one. So meaning for tachometer also, V naught is the output from the tachometer. Okay, V naught proportional with the, because this is the tachometer will be rotate and then this is consider our speed. Okay, this is our speed. So d theta over dt. So you can get this one. We create a one constant coefficient. Let's say we put kt and then we Laplace inverse Laplace d theta over dt. You can get this one. Okay, this is the equation represent to our tachometer. So from here, this is our output, this is our gain, and this is our input. Okay, let's say we draw the block diagram. This is what? This is plus. And then ni apa? Output, V naught. Okay.
V naught.
Okay, and then this is our speed. Okay. Angular. Okay. Tachometer. Okay, this one. Okay. Output over input equal to SKF, because KF or sometimes they put we can put any label, or you can, because for the constant coefficient, this is you have to refer to question. Okay, you have to refer to question. Some normally the question already given the coefficient constant represent for the system. Okay. Okay guys, can you try this equation? Boleh buat tak? Can you try this equation? What you can see from this electromechanical system? Siapa boleh bagi tahu madam? What subsystem you can derive or you can list from this complex electromechanical system? The first one.
ES equal to apa dia tu? E2.
Subsystem. Bagi subsystem dulu. What is subsystem? Sekejap nama ni apa pula ni. Okay. Subsystem. Apa subsystem you can derive from this complex system? The first one.
Field
Ni
circuit.
apa ni? Dekat depan ni field Okay, field. Tak nampak sangat lah. Okay. Sebab dekat sini bila Madam zoom dia dah hilang tau. You see the first one is a field circuit. Control apa? Control DC
Motor.
generator. DC generator sebab tak nampak tu. This is G Okay, ini adalah F. Ini adalah, tengok semua hilang dah. Bila Madam zoom dia jadi hilang. So ini adalah R, F dan ini adalah LF. And then of course dekat sini ada I feel. Okay, I feel current field. Okay, the first subsystem is a field circuit control DC generator. Okay, the second one, apa subsystem dia? You boleh derive apa? DC generator kan? So apa equation dia? You can derive DC generator. Okay, dan number 3. Apa you nampak dekat loop ni? Ni apa ni? Armature. Betul tak? Armature control apa? DC motor. Yes, armature control DC motor. So next yang keempat dia, kita derive lah motor tu. Okay. You derive motor. Okay, apa dia? Ada lagi tak? Number 5?
Rotation.
Yes. Number 5 is a rotational mechanical system. Okay, kita ada 5. We have 5 subsystem. Okay. Ada lagi tak? Any system or any subsystem you can derive from here? Ada lagi ke? So ini adalah damper, okay? This is a viscous damper. Okay? Nampak lah. Okay. Ini adalah damper. Dia tak label. Yeah. Okay, this is damper. Okay. So guys, no, what is the transfer function? Okay, this is also we change not omega. Actually the question is they give you omega. What relationship between omega and angular? What relationship between omega and angular? If you refer to the textbook, okay, omega equal to S theta S. Okay, omega. Omega is a angular velocity. Okay, omega is a angular velocity. Theta is angular displacement. Okay, that relationship between angular velocity and angular displacement. Okay, omega, W ni is omega. What's the relationship between omega and angular displacement? Is that omega equal to S theta S. Okay. So from our example, oh my god, we find angular. What's this? We cancel out this one. You have to obtain the transfer function theta over applied input. Okay, cuba buat. I give you 10 minutes. Boleh tak? Boleh tak? I give you 10 minutes to solve this example. Let's try 10 minutes. We have 5 subsystem. Okay. The equation sama saja. The equation is fixed macam yang previous slide. Okay. The equation is fixed. Okay. So from the field circuit, so you have to derive the field circuit first, and the second one you have to derive the DC generator. The third one armature. You use the Kirchhoff rules. Okay, you have to use the Kirchhoff rule. And then from the DC motor, what equation you can derive? And the last one is a rotational mechanical system. What equation you can derive from the mechanical system? Okay, I'll give you 10 minutes. Try list the equation. Follow the subsystem. Okay, cuba. Cuba buat. Let's try. Angular velocity. Okay, in terms of time, equal to d theta t over dt. So, V Laplace, we take V Laplace transform, we can get this one in terms of S domain. Okay, S theta S. Theta is a position angle. It's a theta or angular displacement. Okay, theta is a angular displacement or position angle. Or position angle. Okay. Siapa dah siap? Who finish? Who complete? For is that our first example? Martin, biru. Okay, siapa nak cuba? Who want to try? Subsystem number 1. Subsystem number 1. What is the equation you can derive from there? Guys, what system?
ES.
Sorry?
ES.
Boleh?
Equal.
Betul lah, because that one is the input kan. We start equation with the input, our applied voltage. Okay? So meaning from here.
ES equal to RS plus LF.
Okay. RF plus LFS multiply with the current field. Is it Saleh? Then?
IF. Ya,
Okay.
betul.
Okay, so from here, we directly draw the block diagram. Okay, but before that, we have to identify how about our equation is based on output equal to gain multiply with the input. So meaning, of course, this is our input, right? Okay,
Yeah.
if voltage our input, so meaning our current is our output. So you have to rearrange. So meaning how to rearrange, meaning IFS equal to 1 over
1 over RS plus LF.
yeah, and multiply with our applied voltage.
Yes.
Okay, so finish our question and then write your block diagram. And then this is 1 over R plus LLF, and this is our input, and then this is our output. Okay, finish our first subsystem. How about the DC generator? How to define, how to derive the DC generator? This is for number 1. How to derive DC generator? Macam mana nak buat DC generator? Apa equation DC generator tadi? What's the output? Because we know when current through the generator, there will be generate apa? There will be generate water generator, right? Okay. From our circuit or from the schematic, our water generator is equal to what? From our generator, equal to what?
IFS.
EG.
Water generator.
IFS.
Water generator. What is question?
Current.
Water generator. Apa kita boleh buat water generator? Tadi mana? Mana water generator kita? Generator. Mana generator? Hold on. Where is our generator just now? This one. When current through the generator convert mechanical rotation into electrical voltage. So there you come up with the voltage, right? So you can derive apa? Apa yang you boleh derive dekat water generator ni? Ni. Water generator ni apa yang you boleh derive kat sini? VG kan? Potential of generator. VG, right? From the example.
Yes.
So you derive VG proportional with the IF kan? Ni.
IF.
Betul tak? Sorry, not this one. Oh my god. Okay.
IF.
IF. So meanings VG proportional with the IF. So you rearrange, you can get this one, right? Okay. So same goes to our example. So apa kita punya output generator from this one? What's the output our generator? Cuba tengok betul-betul. What's the output generator kat sini? Apa saya label kat situ? EA boleh
G.
tak? EA kan?
EA.
Okay. Yeah, EA is a output generator. Okay. So, apa equation dia?
EA equal to EG.
Proportional dulu. Kena buat proportional dulu. Yeah, come up with the proportional first.
Proportional
meanings?
to IF.
Yes, very
EA
good.
proportional to IF.
Yeah, correct. So, equation dia EA proportional with the IF. Okay. So, jadi EA equal to, so kita ambil one coefficient constant, that one generator kan? we put kg IFS. So ni pun kita buat dalam S domain EAS. Okay. So apa kita punya output input from here? What is our input and output from equation number 2 ni? So the first equation IA is our output. So meaning the next system
EA
IA the first system the first system tadi IA IF adalah output. So the second system IF is your input lah. Your input sebab dia bersambung kan. Okay. So meaning this one input, this one output, and this is your gain, right? So you draw the block diagram. Then this is the kg, the gain. And apa input dia? Input dia adalah IF. S dan output is a EA. Okay. Boleh follow?
Boleh.
Okay, the next equation, armature. Armature control DC motor. So apa equation you can derive from the armature control DC motor? Loop tu. Apa loop dia? Apa Kirchhoff law kat sini? So bila you nak derive armature control DC motor, tutup ni dulu. Okay, so maksudnya ada satu loop dekat situ. So meaning this is our EA. So this is our apa? So ini adalah R. Okay. Dan ini adalah inductor LA. Dan dekat sini ada EB. Okay, ni EA tu EB. So apa equation dia? Kirchhoff. Dan dekat sini current IA. So apa equation you boleh derive? What equation you can derive from here? What's the input? Input EA lah kan?
Yes.
Yeah, input is a EA. EAS equal to
VRA.
VRA lah kan?
Yeah.
Okay, kejap ya. Yep. Hilang pula ni korang. So, kita buat, let's say lah, katakan, okay. VRA plus
VLA.
Sorry. Okay. Plus dengan VLA and plus dengan V kan? Total of voltage kan? Okay, so ini sama dengan RA plus, ini impedance dia, LAS, darab dengan armature current kan? Okay, and plus dengan EBS. Okay? Right, so jadi you rearrange this equation. So you can get EAS minus EBS equal to RA plus LAS darab dengan current armature. Okay, so you arrange this equation, follow output equal to gain darab input. So what's your input? Current or voltage? Which one your input? From this equation, what is your input? Current or voltage is your input?
Voltage.
Okay, input is our voltage. Okay, so from here we can get IA. Oh, sorry. We have to rearrange. So meaning this is our current output equal to gain. This is your gain. LAS plus dengan input. Input is EAS minus EBS. Okay. So from there we draw the plot diagram. Because this is your input F minus, right? So meaning you have a summing here. Minus, this is for EA and this is for, this is for EB kan? This is your EB. And this is the gain 1 over RA plus dengan LLS. And what's the output? Output is the current. Okay guys.
Okay.
Okay, the next one, DC motor. DC motor. Berapa equation? How many equation you can derive from the DC motor? How many equation you can derive from DC motor? Tapi ingat yang tadi yang kita buat sebelum tu. So first we derive the EB. The second one we derive torque. EB apa tadi? EB proportional with the speed. D theta over dt. And torque proportional with the armature current. Ingat tak? Kita punya previous slide. Okay, so you have to derive two equation from DC motor. From DC motor. Okay, DC motor. First one we derive EB. EB proportional with the speed. D theta over dt. Okay, so we simplify this equation. You can get EB equal d theta over dt, and then we get the one coefficient. We label with the back MF KB, and inverse Laplace you akan dapat S theta S. Okay, ni apa buruk S ni? Can get this one. Okay, this is for back MF. Okay, so meaning number one is for back EMF. So number two, torque. Torque, apa equation dia? T proportional with armature current. Okay, so we simplify, we can get K for torque. T km, sorry. Km for motor torque. Km multiply with this one. Yang ada S Okay. So jadi, how about this equation? Is it the condition is the output equal to gain direct input? So we have two equation dekat sini. So ni equation ni. Is it they follow the output equal to gain multiply with the input? The first one. EB equal to KBS theta S. Okay, which one is our input? From the first equation DC motor, EB equal to KBS theta S. Mana satu input, mana satu output? Which one input, which one output?
EB input.
Okay, EB input because remember tak dekat sini tadi? Kan? Betul ke? Input ke tu? Kalau dekat apa tu? Kalau EB tu input, sebelum tu apa? Sebelum tu?
Output.
Sebelum tu dia output lah. Cuba tengok. Cuba tengok dekat sini. Ni equation ni. Selalunya kalau kita buat proportional, ini adalah output kan? Dan speed ni, d theta over dt, ini adalah speed. Speed ni adalah input. So, kita derive equation ni, kita simplify equation ni, so you can dapat this one. So, EB tu adalah kita punya output. Okay, because sebelum tu tadi, the previous system, EB is our input, right? So, meaning before that, before EB going to be input, this is the output. So, meaning from here, so this is, this is the output, this is the gain, and this is the input. Angular is your input. So, macam mana nak buat? So you have to rewrite, is it? Suppose you want to rewrite or not? Not necessarily, tak perlu rewrite kan? No need to rewrite because you already represent in term of output equal to gain direct input. Okay, so you draw the block diagram. So from sorry, mana ada samping. Okay, so block diagram. This is the KBS and this is the EBS and input is a theta or angular. Okay? Ni E. Besar ni video. Ayah. Ini adalah EBS. Okay. So the second system torque T proportional with the IA. So T is our output. IA is our input kan? Betul tak?
Yes,
Okay,
betul.
okay, right. So just now this is our output. This is gain and this is our input. Okay, so from here you can draw the block diagram, individual block diagram. And then this is a torque. And this is a km. And this is your current. Okay. S. Okay. So DC motor will be, you can derive two equation from the DC motor. Okay, the next one. Apa lagi tadi ah? Apa lagi? Tak lupa dah. Okay. Last one. Rotational mechanical system. Rotational mechanical system ada inertia and ada damper. Okay, ada inertia and ada damper. My God. Okay. So, let's derive. Apa equation untuk rotational mechanical system? Rotational mechanical system. Apa yang kita boleh derive? What's equation for rotational mechanical system? Apa ni? Apa yang you boleh derive? Apa dia punya tu torque. Torque equal to, apa dia punya impedance? Initial kan? JS squared. Ya, plus dengan damper and multiply with the theta kan? Theta S ya, in term of S domain. Okay, so which one input, which one output?
Torque input.
Yeah, good. Torque input, this is your output. So you have to rearrange our equation. Theta equal 1 over gain dia kan? ds squared plus ds plus ds and multiply dengan torque. Okay. So now we can get, this is our output and this is our gain and this is our input. Okay. So from here, kita buat block diagram. Block diagram dia. So ini adalah torque. This is the gain, ds squared plus ds and the output is a theta s. Okay. So kalau Allahu Akbar. Okay. Kalau kita tengok kita ada berapa block diagram. So you have to combine all the block diagram. Okay. So how many individual block diagram we have? one for DC generator, one for V circuit, one DC generator, one armature DC, one armature circuit, two DC motor, one rotational mechanical system. So ada berapa individu? 1, 2, 3, 4, 5, 6. We have a 6 block diagram. Okay, so you have to draw the overall block diagram. So how to draw the overall block diagram ni? Macam mana nak combine? Kita ada, we have 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. How to draw the functional block diagram or how to draw the overall block diagram? Boleh tak how to draw the overall block diagram? Macam mana nak draw overall block diagram?
Boleh.
Cuba buat. How to get the overall block diagram?
ES.
Combinekan semua tu kan?
Combine semua.
So
Lepas tu
meaning,
simplify kan.
so dekat sini apa tadi? First ni. So ini adalah
ES.
okay.
Lepas tu dalam kotak tu 1 over RS plus LFS.
Plus LFS.
Lepas tu output dia IF. Lepas tu ada kotak KG.
KG. From KG ni output dia
Ada output dia EAS.
EA. So kat sini ada summing kan? So kat
Yes.
sini ada EB. Okay, kat sini ada EBS. Dan dekat
Ada
sini
negatif EBS. Lepas tu situ ada kotak
1
1 over
okay, LS. Lepas tu apa lagi tadi?
lepas tu IAS output dia sambung ke ni
Kat sini apa? Apa tadi? Dan dekat sini
KBS.
M.
KBS.
sure ke?
KM.
tak sebab
KM.
KM
Kan?
yes
KM, lepas KM akan ada torque kan?
yes
Yes.
TS
Okay, akan ada torque kat
ada
situ.
1 over T AJ S square plus DS.
Ya. So kita masuk dekat torque lah mak. Sekejap. Eraser saya dah tak function.
Madam,
Ya.
back EMF tak masuk
Ada, tunggu sekejap.
Oh, okey.
Ada, sekejap.
Pada
Apa tadi? Apa dia punya output kat sini? Torque kan?
Yes,
Torque.
stop.
Torque.
tak.
Lepas torque ni dia akan masuk kepada, ini adalah dia punya gain.
1 over JS square.
JS square.
And output dia adalah theta kan?
Yes.
Okay, ingat tak
Lepas tu
tadi
dia akan jadi
ingat tak tadi EB sama dengan
yes,
D theta over
DT.
T kan? Okay, dekat
Yes.
sini kalau kita simplify, kita akan dapat EB sama dengan KB, lepas tu D theta over DT kita inverse Laplace, so you akan dapat S theta S. Kat sini lah dia nak sambung Din. Kan?
So output
B theta. Betul tak? So
masuk
daripada
daripada tu ke
theta
sini.
ni masuk balik.
Kat tengah tu ada KB.
So ini masuk kat sini Din. Okay.
KM.
Okey.
Dan dekat sini ada KBS.
KBS.
Okay tak?
Okey.
Okay, habis. Macam tu lah. This is overall block diagram or completed block diagram. So, apa kita punya transfer function kita? Transfer function kita adalah, ini adalah output kan?
Yes.
Okay, this is your output. Okay, this is your output. And then input kita tadi adalah, output kita tadi adalah this one. Okay, ini adalah kita punya input. Okay, so jadi transfer function kita adalah transfer function angular displacement over
ES.
okay, so kita kena cari lah ni sama dengan apa. So you all kena solve kan, yang ni boleh combine dululah. Yang
Buat
ni
yang belah kanan dulu.
so A dengan B ni boleh combine. So cascadekan dua ni. Kan? Betul tak?
Yes, betul.
Okay, you cascadekan dua tu. So you akan dapat A, B.
Betul.
Lepas tu buat yang dalam loop pula. So ni dalam ni.
Cascade
Okay.
1 over
So let's say lah madam buat
A1, A2, A3.
sekejap madam labelkan. Madam buat ni A1, A2, A3 dan ini adalah B1.
B1.
Okay. So ni akan jadi
A1, A2, A3 over
A2, A3.
A3.
So ini adalah
B1.
1. Okay. So dia akan jadi ini adalah angular displacement. Okay. Macam tu lah. Dan ini adalah PS. Okay. Lepas tu loopkan dulu. Okay. So you kena minimizekan yang feedback tu. Kan? So minimizekan feedback. You akan dapat apa bahagian sini. Sekejap ni slow ni kenapa ni. Sekejap. So minimizekan bahagian sini. So meaning ini adalah apa tadi dekat sini? Ini adalah apa? Apa tadi yang EA
EB.
kan?
EA. Bawah tu negatif
EA
EB.
dan dekat sini adalah EB. Okay, so untuk bahagian sini, transfer function ni sama dengan apa? EAS
Equal ES.
Sekejap. Terbalik. Sorry. Output dia theta lah. Sekejap.
Delta S.
Madam punya whiteboard ni dah nak merajuk dah ni. Okay, transfer function dekat sini adalah theta
Delta S
over
over EAS tolak EB.
So sama dengan A1, A2, A3 over A1, A2, A3 darab B1. Okay, ini adalah transfer function. Sorry, 1 ni minus, sini plus. Okay, this is for feedback. This is for simplification for feedback. Okay, let's say this one madam buat equal to X. Okay, so and let's say after you can get X, you multiply with AB. Let's say you multiply with this one, Y. Okay, so last equation dia apa? Apa last equation?
YS.
Betul. Okay, the last equation apa transfer function dia? Sekejap what is the transfer function?
Delta S over ES equal to YS.
Yes, good. Over ES equal to X and cascade dengan Y. Cakaplah ni. Okay, habis. This is the way how to define the transfer function from electromechanical system. How? So far so good? Guys? Good. Okay, very good.
Good.
So far good.
Good.
Okay, right. Okay. So, habis. We complete our chapter 3. And then madam have one question for your homework. Mana soalan? This is the question. But the example or exercise. This is, let's try. Homework. The armature control DC motor. Okay, where is armature? This is armature. Ni armature. This is armature control DC motor. Okay, this one. The armature. Okay, slow. Armature control DC motor. Okay, this is armature control DC motor. This one. Armature control DC Motor. Okay, is used to drive inertia. Okay, so maksudnya ini adalah kita punya plant. Okay, plant kita ada inertia, ada spring, ada damper. This is our plant. Okay. And then our output apa? Output kita adalah, kat sini ada T and theta. Okay, kat sini ada torque and angular. Output kita adalah angular. The circuit receive voltage supply from the output of amplifier K. Okay, kat sini supposedly kena ada output, kena ada input pada armature kan? Okay, so you kena define satu, apa yang you nak label kat sini. Okay, output dekat sini adalah apa? Ini amplifier. Okay. Kenapa medium punya circuit ni hilang? Sekejap medium tengok sekejap. So dekat sini lah, let's say medium bagi input VI. Okay. So jadi you have to create apa voltage kat sini you all nak create. Ni amplifier. Amplifier ni medium dah labelkan dengan K. Dia punya dia punya coefficient constant dia K. Okay, so macam mana nak buat? Macam mana nak buat ni? Agak-agak macam mana nak buat? So ini adalah kita punya input So medium label lah. This is our input. Ya Allah. Dia dah slow ni. So ini kita punya input. Okay. So apa yang you all nampak dekat bahagian sini? Ni circuit apa ni? Siapa boleh nampak? Apa circuit dekat situ? Siapa boleh nampak? Okay, siapa boleh nampak? What type of circuit there? Dan dekat sini let's say medium buat VR2. Okay, apa you all boleh derive circuit kat situ? Mana semua orang ni?
Potentiometer.
Derive.
Apa dia? Tak dengar?
Potentiometer.
Yes, potentiometer. Betul. So apa equation yang you boleh derive kat situ? Apa? VDR. Betul ke tak betul?
VDR.
VDR kan? Okay, so jadi let's say lah kalau madam draw balik, dia kan jadi macam ni. So ini adalah input. Betul tak? Ini adalah VI kan? Dan ini adalah R1 dan ini adalah R2. And then madam nak measure dekat sini. Betul? Sama tak?
Betul.
Pandai pun. So apa equation yang mula-mula kena buat? So first maksudnya potentiometer lah kan? Betul tak? The first one adalah potentiometer. Okay, so label. Okay, untuk subsystem 1 kita buat potentiometer. Potentiometer kita guna V, D, R. Okay tak? So jadi apa? VR2
VR2 equal to R2 over R total.
Nampak R1 kan?
R1, yes, time VI.
VI. Okay, ini adalah equation number 1. Lepas tu you solve kan lah. Yang mana input, yang mana output, yang mana gain. Boleh tak? Habiskan.
Boleh.
Madam nak tengok you all hantar dekat WhatsApp. Hantar kat WhatsApp lah. Malas nak buka PC cewa. Hantar kat WhatsApp. Boleh? Sebelum Jumaat. Jumaat kita punya kelas kan? Boleh tak? Madam nak tengok sampai overall block diagram. Lepas tu you all dah pandai dah macam mana nak solve. Okay? Boleh? So lepas nombor 1 ni, lepas nombor 1 ni nak buat apa? Apa sistem dia? Yang kedua. Apa yang kedua? Ni, amplifier. Amplifier pula. Itu equation yang nombor 2. ataupun subsystem number 2 the amplifier. Siapa bunyi tu? Line dah slow. Okay, tak apa. Dah sampai pukul 1 dah. Nanti cuba ni. Yang number 2 amplifier. Cuba dapatkan equation dekat amplifier. So let's say lah saya bagi label dekat sini adalah EA lah juga saya bagi. EA. Okay. So dekat amplifier tu apa equation dia? Lepas tu master control DC motor. Lepas tu and then apa kita punya apa ni? And then DC motor tu used to drive the rotary mechanical system. Try buat ya. Okay, boleh tak cuba? Homework ya.
Boleh.
Okay, madam dah tolong solve dah the first one tu. Okay, so I nak tengok the electromechanic, the complete block diagram for this system. Okay. So, kita stop dekat sini, right? We stop our class here and then kita akan jumpa, we will meet again on Friday. Okay guys? Mana senyap je geng-geng lain ni?
Okay.
Okay. Mana our geng Philippines ni mana? Max, mana lagi? Justin, John, Carlos, where you guys? Is it okay? Is it you can?
Yeah. Yes, madam.
Okay, you can follow our class.
Yes, madam.
Okay, very good. Okay, right.
Yes, madam.